Question 22. There's 0.15 milligrams of epinephrine in an EpiPen. How many molecules, right? And so this is a question more of like what Sean was talking about. And then, yeah, to answer Daniela's question, right? If you can do this confidently, if you feel comfortable with these calculations, you should be good. Like I can tell you today, right now, there is going to be a question like the question we're looking at right now. There's a question like 22. There's a question like 23 on the exam. Is the mass the same? No. Is the formula the same? No. But the steps to solve it are going to be the same. The same with question 23, right? Is this mass going to be the same? Is this formula going to be the same? No and no, but the steps to solve problems like 21, 22, 23 will be the same, right? So you will see questions like 21, 22, 23, right, on the exam. I can tell you that very confidently because I wrote the exam yesterday. All right, so let's do question 22. All right, so we want to go from milligrams to molecules. Again, our molar mass is in grams. So step 1, milligrams to grams, the metric system, right? Step 2, grams to moles. And then this is just one more step in our last problem. Now we want to go from moles to molecules. And so here's where we need Avogadro's number, right? So we're looking at 3 steps, right? 1, 2, 3 steps, right? Step 1, got 0.15 milligrams, right? We know in 1 gram, there's 1,000 milligrams. So we've got 0.0015. No, it's more than that. There should be 3 zeros in there. Yeah. Grams of epinephrine, right? Now we can find the moles. I gave you the molar mass. So I've got 0.00015 grams. The molar mass tells me for every 1 mole, 183 grams. So we divide that by 183 and I get 8.19 times 10 to the minus 7 moles. The last step, right, moles to molecules using Avogadro's number, 8.19 times 10 to the minus 7 moles. Avogadro's number tells us in 1 mole of anything, I need to have 6.02 times 10 to the 23. In this case, molecules, because we're looking for molecules. So multiply by Avogadro's number, all right, 6.02 times 10 to the 23. And hopefully we get a number that's there. Okay, good, yeah. All right, I get 4.9 times 10 to the 17 molecules, right? Milligrams canceled in the first step, grams canceled here, moles canceled here. We're left with molecules, and that's what we're looking for. So the units should, right, check out. 2 sig figs because 0.15 milligrams is 2 significant figures. So I would go with choice A, 4.9 times 10 to the 17 molecules, right? Yeah, Janice, dilution is fair game. And then I don't know if I'm pronouncing your name correctly, Zayed. Ammonia, water. I mean, I'm not going to be asking you like the polyatomics, the 6 polyatomics, you should know those. But then for like other common compounds, yeah, I'm not going to be asking you too much. I mean, I'm sure we all know water, but as you've seen here, like I don't expect you to know the formula of things like caffeine. I give that to you, or of epinephrine, right? I give you those formulas. So there shouldn't be too much of like random molecules that you have to memorize. Correct, Paris, right? And I think that is the next problem, right? Question 23 is that like that's the only difference. There's one additional step. The last step would be to multiply, because we know for every molecule, how many of those specific atoms do you have? So that sets us up nicely for question 23, yeah. Right, how many oxygen atoms are in 85 milligrams of caffeine? Right, so the same process. I want to go from milligrams to grams. Once I'm in grams, I can go to moles. Moles, I can go to molecules. And then once I'm in molecules, right, I can use the formula to say how many oxygen atoms do we have? So yeah, that's correct, Paris. So yeah, just like the previous one, right? Steps are going to be the same. Numbers are different, right? 85 milligrams. I know there's 1,000 milligrams and 1 gram, so 0.085 grams, right? Moles, 0.085 grams. The molar mass tells us somewhere here, right? 194 grams per 1 mole of caffeine. So 0.085 divided by 194, I get 4.38 times 10 to the minus 4 moles. All right, step 3, we're going to bring in Avogadro's number. So 4.38 times 10 to the minus 4 moles. Right, Avogadro's number tells us 1 mole is going to have 6.02 times 10 to the 23. All right, moles cancel out, multiply by Avogadro's number. 6.02 times 10 to the 23. And I get 2.637 times 10 to the 20 molecules. And like Paris suggested, right now, because we're looking for oxygen atoms, right, the last step would be the last conversion. Got 2.637 times 10 to the 20 molecules. We know in 1 molecule, right, we go up to the formula. The formula here tells us I've got 2 oxygen atoms. So we multiply by 2, right? Not that complicated. And we get something like 5.28 times 10 to the 20th, which is hopefully an answer there. And it is, yeah. All right, so choice D. All right, and this is atoms. So again, mass could be different. Formula could be different if asked for a different unit of oxygen, not atoms. That part, would that part come earlier like moles? Yeah, so if I asked you, like, how many moles of oxygen are there in this sample? You're correct. If we were asked how many moles of oxygen were in this sample, we would skip step 3 completely. And we would say, okay, I've got this many moles of the whole thing. And in 1 mole of it, we have 2 oxygen, right? So we would skip step 3 altogether, and we would just go moles of the molecule to moles of an individual atom. We're going to still use the same conversion factor, though, because 1 mole of this molecule has twice as much oxygen. So yeah, we would multiply by 2 right there, be done with the problem. Yeah. All right, question 24. Yeah, this was when I had energy to write the exam. I was like, oh, I'll make all these new questions, add all these pictures in, and I think I added it in 1 picture. Yeah. Yeah, so Sydney McLaughlin, Laverne, we have questions going from mass to moles? Yeah, Sean, we did, right? We did. So this question right here, question 21, right? I gave you a mass of caffeine and I said how many moles of caffeine are there, right? So I kind of like built them up in difficulty. Here's one step, here's two steps, here's three steps, right? Mass to moles, mass to moles to molecules, mass to moles to molecules to atoms. Right, so she won the gold medal in the Paris Olympics, ran the world record 50.37 seconds. I mean, why are we giving that a thumbs down? Like you're gonna have to have those problems on the exam, right? We covered that material and it's one step. Um, so anyways, if anyone knows how hard it is to run a 400 meters, right? Now put hurdles in your way. And yeah, she ran it in 50 seconds, right? Pretty amazing to think about. So yeah, what speed in miles per hour did Sydney run in the race, given there's 1,609 meters in 1 mile? So this is kind of just a dimensional analysis problem. Right, so 400-meter hurdles, and we want to find that in miles per hour. So she basically did, so we can turn 400 meters in 50.37 seconds into like meters per second, and then we can convert that into miles per hour. So, right, 400 meters in 50.37 seconds. For the practice test, yeah, 25 questions, 1 point each. 400 divided by 50.37, right? So that's like 7.94 meters per second. So, all right, meters per second. Let's see. Let's go. We'll convert hours first, right? So we know in 1 hour there's 3,600 seconds. So multiply by 3,600 and we get 2.85. 9 times 10 to the 4 meters per hour. And then next we want to go to miles per hour. We know in 1 mile there's 1,609 meters, right? So seconds canceled out here, meters canceled out here. We're going to divide by 1,609. And we get something like 17.7, let's see, 4 sig figs there, 4 sig figs here. So 17.77, I guess 77 miles per hour. For question 24, if we did not know the exact conversion from seconds to hour, sure, yeah, you could go seconds to minutes, minutes to hours, right? And then Sebastian, everything is multiple choice, yeah. Yeah, binary covalent compounds. It's a type of covalent compound. So we didn't look at covalent compounds that have like 3 or 4 or 5 elements. We just looked at binary. So the molecular compounds that we looked at just had 2 elements in them. And so we only looked at the nomenclature for binary molecules, ones that had 2 elements in them. Yeah. All right, question 25. Yeah, this was the only one that was like a free response question on the practice exam, all multiple choice on the test. So we have our density is 22.6 grams per milliliter. We want to know the volume of this 1.23 kilogram sample. So densities in grams, our volume, our mass is in kilograms. So let's convert our mass first. right? 1 kilogram, 1,000 grams. So I've got 1,230 grams of this sample. Now I can use my density, 1,230 grams. And I know I'm looking for volume in milliliters, so kept that pretty straightforward. My density tells me for every 1 milliliter, right, I'm going to have 22.6 grams. Crazy dense material. So 1,230 divided by 22.6. All right, and I would have a volume of about 54.4 milliliters, right? I would say three significant figures because let's say we weigh out, right, that 1.23 kilogram sample. So 54.4 milliliters, really not a whole lot to get over a kilogram of this material. All right. Stop the recording.